best to show it to you. Hopefully everyone can see the screen. That's not very good. Sorry about that. So as you can see here, this is the main screen that you will see once you log on to the Nabi and you turn on the instrument. And actually, you might not be able to see it, but there's also a light here that will indicate that the instrument is turned on if the screen is in safe mode. And as you can see over here, there's the nucleic acid measurements, which you can go on by clicking that. It's very simple. If you go on to the main page, there's also the protein measurements for Bradford, Lori, BCA, Burette, and direct UV. And for others, you can actually set your own wavelength that you require over here. You can set it as however you want it. If you require the measurement to be at, let's say 500 nanometers, you can just click 500, enter, and that's it. Pretty simple. And we also have kinetic measurements where you can set the measurement time and interval, and also the wavelength, and the Nabi will continuously measure. Let's say you set the interval as 1 minute and you set the measurement time as 60 minutes, then you will measure, the Nabi will measure every minute for 60 minutes, so 60 times, and you'll be able to see the graph of the concentration change, or however you want it. So we also have spectrum measurements where you can set the wavelength range. So let's say 200 to 850, which is the general wavelength that most people use, most commonly used wavelength. And you can, and if you start measuring, you have to set the blank first, obviously. But if you start measuring, it will measure between 200 and 850 for the whole spectrum in 1 nanometer increments for the whole spectrum for the sample. And it will show you a graph as well as show you the peak wavelength. It will be displayed here and the absorbance at that wavelength. And you can also search which wavelength to look at. So if you measure between 200 and 850 and the highest peak was at 360, but you want to see what the absorbance was at 400, all you have to do is type in 400 here and click the search button right next to it. Now, we also have the endpoint where you can set up the wavelength and just measure the absorbance continuously. We also have OD600, which is for cell counts. So wavelength is set at 600, and you can measure them continuously just by setting blank and pressing read. So I'll just show you a couple of demonstrations on how to use the nucleic acid and protein measurements. So you go on to nucleic acid. For nucleic acid measurements, usually, since the DNA samples are very expensive, that's why there's a micro volume measurement, so that you don't have to use that much samples at once. Also, if you want to measure nucleic acids using a cuvette, you're going to have to get a very expensive quartz cuvette as well. So for measurements, let me just get my pipette and disposable tip. First, what you need to do is, just in case there's any contamination here, you just wipe this using Kimtech or any wipes, clean wipes that you have. Take the blank here, which is actually TE buffer. So for DNA and nucleic acid measurements, you need TE buffer. And you pipette it and drop it onto the pedestal. So if you'd like to take a look, There's the little pedestal that we use, and there's the little, I'm not sure you can see it that well, but there's the little bubble of buffer on top of it. And this, which I forgot to mention, is what we call a cuvette stick. So when you're measuring micro volume, because the results may differ depending on, because of the cuvette measurements going on at the same time, you just need this thing to cover the block. And this is obviously provided with the instrument. Next, all you have to do is close the pedestal. And click blank. Yes. Then you'll hear the sound of the motor moving. So it's basically adjusting the length that the column is made so that you can measure, and that's that, and it's already done. So next, you wipe it. And we do recommend use blanking at least twice in the beginning, right at the beginning, because there may be a slight contamination of the pedestal in the beginning from not using it for a long time. There might be dust that you don't want messing up your results with. Blank again. Yes. Next, you take a sample. So this is our QC sample that we use for quality control. It's a salmon sperm DNA from Thermo Scientific. And when we measured this morning, it should be at around 165 nanogram per microliter. So I bet this much. And put it on the pedestal. Close and click read. And voila. Right. So as you can see, if the result is not what you expect, or it's very simple, it means I did the blank wrong. Sorry, I need to actually stand up and do this. Otherwise, it's a bit uncomfortable. So blend again. And if you read again, excuse me, it's been a while since I've actually done a demonstration due to COVID and stuff, so I seem to be getting the pipetting wrong. So when you're pipetting the blanket, really you need to be really careful. Otherwise, if the blank is wrong, then the results will also be wrong. So it needs to be done very carefully. So this is very embarrassing, but please bear with me for a second.
예. 아, 이거 통통 왜 통화탑? 저 지금 미팅 중입니다. 네.
Sorry about that. Yep, finally the blank is correct. It's been a while, so if you look at the results, it's 168, so it's 3 different from what we measured in the beginning, in the morning. So about 3 over 168. So the CV for most of our measurements is around 3%, less than 3%. Not for most, for every measurement, it should be less than 3%, and with 3 over 165, it should be around, let's say, about 1.8%. And you can tell that the sample is pure by looking at the ratios, mostly the 260 over 280 ratio, which if it's over 1.8 and in between 1.8 and 1.9, it means the sample is very pure. And for 260 to 230 ratio, if it's over 2.0, then that's fine as well. So when you heard the measurements going, you probably heard one bleep. So I'll let you listen to it once again. One second. So that's the sound of the motor moving and one measurement. The pipetting is a little bit difficult if you're not a skilled technician, which unfortunately I am not. But I do practice for demonstrations, but it's been a while, so please bear with me. Yep, sorry about that, 161.4. So if you hear one distinct measuring sound, that means it's measuring at the first step. There are 3 steps in total. First step is for low concentrations, 2 steps is for medium concentrations, and 3 steps for high concentrations. So as you can see, intra-measurements CV as well is actually pretty good for an instrument, as long as you get the pipetting right, which unfortunately I'm not doing that well. And if you hear 2 distinct sounds when it should be 1, then that means you've done the pipetting wrong, like I did. So let's just move on from this sample. Let's go on to what should be 600, but what we measured is around 675 in the morning. The DNA samples, if you leave it, if you dilute it, let's say about 12 hours ago, and then you leave it out for a while, then it will go up because of the evaporation. So if you move this, so 503. But as you can see, that this is very wrong results because of the ratios, 2.473 to 3.839. I probably should have invited our engineer here so that he can pipette it properly for me and do the demonstration, but since none of the English-speaking ones are currently available, I have to do it myself. Apologies for that. All right, so 781 to, yeah. So when you're done measuring, you have to make sure to wipe this area, the pedestal clean. And also show you the 1300, or what should be 1300, which is around 1350. And you'll be, because this is medium concentration, you'll be able to hear two measurement sounds, or three, depending on the concentration. Right, with results like this, the best thing to do, not to panic, just blunt again. Most of the time, the problem if you're getting faulty results is if you look at the pedestal here, when you're pipetting, you don't get it onto the little, there's a small hole in the center of the column where the light goes through. If you don't get it onto that column, then usually the results will obviously falter. And there we go, that was the 600 that we used before. And 1,300, 75. And again, 1,372. So for that, for DNA measurements, all you have to do, and you can also search. Oh, oops, you can also search for the data that you did just by clicking search at the top of the screen, and you can go into, you can search for anything within the screen. You can look at DNA, RNA, protein, OD600 endpoint, and if you search all, then you can see all the results that you did with the timestamps and everything. And you can also delete it. You can do data transfer here, or you can change the title of the essay that you just did, so that maybe you can, it's by default, it's called untitled 01 and 02. And if you go back to the main screen, you can go. So for nucleic acids, our Nabi does not, basically, it does not support cuvette measurements, because you will need a special type of cuvette for nucleic acid measurements, basically quartz cuvettes, and it requires a lot of samples, and most people do not use it, so we decided not to add that function for it. But for everything else, you use a cuvette measurement for it. So all you have to do is remove this. So let's try a cuvette measurement with the cuvettes, the samples we have ready here. We have OD600 measurements ready. So when you're measuring with a cuvette, you gotta get the blank, which is usually just distilled water. If you look at the cuvette, usually you will see an arrow marking which way it should go. And for Nabi, there's also an arrow next to the cuvette insertion area over here. You can see, I'm not sure if you can see, there's an arrow over here that you can see to where basically which direction you want your cuvette in. So all you have to do is match the arrow with the arrow and insert plus blank. Just in case, one more time. That's it. For cuvette measurements, very quick, very easy, very simple. Now, this one, let's go to this, we just click insert the cuvette, click read, and you can see the concentration, the absorbance that comes up, which is 0.581, which is and when you're measuring cuvettes, it's not recommended to measure straight afterwards. I mean, you can read like this, and then you click again and read. But this can result in fluctuation. So we usually, due to there being, these cuvettes are very sensitive. So if you measure too many times at once, then there might be black spots that appear on the cuvette, and that might screw with the results, so skew the results. So we recommend at least waiting about 3 to 5 seconds before measuring again. So you can see 0.581, 0.578, 0.582, so pretty standard. And you can see here, to measure this, which should be higher concentration, 0.869. 1, 2, 3, 0.870, 0.871. So very good CV. Should be about less than 1%, I'd say. That's it for the cuvette measurements. I mean, for all these 6 cuvette measurements are very easy. They're not difficult at all. All you have to do is make sure to put in the cuvette in the right direction. Really should not put it in a different direction. For example, if you're supposed to put it like this, but if you put it in like this, then the measurements will be very weird. So if you're getting weird measurements from the cuvette, first try re-blanking, and second, make sure that the cuvette is in the right direction that you want it to, with the arrows pointing the same way. Now for protein measurements. So for direct UV, for protein, we have cuvette measurements for everything else except for direct UV, because direct UV measures at 260 and 280, which is the UV range. You can see here 260 and 280. And for UV range, you cannot use the normal plastic cuvettes. You will need to use quartz cuvettes, because plastic cuvettes cannot have that wavelength pass through it. So that's why for this we use the micro volume as well. So insert the cuvette stick to stop the light from going in there. And next we have protein samples. As I mentioned before, for nucleic acids, you use a TE buffer. But for protein measurements, you use distilled water as a buffer and blank. So you insert the DW. Oops, that's very wrong. Place it onto the pedestal. Close. That's blank. Oh yes, I forgot to mention, but for micro volume, the sample size that you need is 1 microliter. So for example, all you need is 1 micropipette that can do between 1 and 10 microliters. But we do recommend using 1.3 microliters or 1.2 to 1.3, because for 1 microliters, the results may slightly vary due to there being not enough sample to make the column properly. So the technology is that this part of the pedestal and the bottom part of the pedestal basically hold the bubble, the little sample in between itself, in between the 2 pedestals, and it will move up and down to make a column of sample, and the light will pass through that column. So depending on how concentrated it is, the pedestals will be further apart or very close together. So for higher concentration, the pedestals will be closer together so that it can measure more accurately. And as usual, in the beginning, it's recommended to do blanking at least twice. Next, let's take this sample. And when you're pipetting protein samples, they're very easy to pipette incorrectly due to their viscosity. It's easy to make bubbles form, so it needs to be done very carefully. If there's a bubble on the column, then it won't measure properly. So you need to do it very slowly and take your time pipetting it. Not to panic. Don't panic. Just need to blank it again. Making sure that the blank is properly above the pedestal. Close blank. And put the sample. And you can see this is the correct graph for proteins. So it has 2.265 at 10 nanometer path, 10 millimeter path, 280 at 3.344 path. So if you see a graph that doesn't look like this, with a peak around before 200 nanometer wavelength and a little bit of dip and going back up to the peak at 280, if the graph looks different from what it is shown here on the screen, and that would mean that you will need either the sample is contaminated with something else, or it would mean that you will need to pipette the sample again. So if the graph looks wrong, we just recommend doing it again. And we'll try it with a different concentration so you can see. Oops, okay, that's very wrong. As I mentioned, for protein samples, it's very, you need to take your time and be very careful, otherwise it will form bubbles when you're pipetting it. And 3.297. So again, CV very good with the graph looking exactly in the same shape. And let's try with a higher concentration sample this time. .8, right, which is correct. Next, try again, and as we see, the graph again, the values might have increased, but the graph shape should be the same. Yeah, let's see. I'll just show you just as an example, this is how it looks when it has bubbles on top, and that does burnt. If it has a bubble, then you really should not measure it because that will basically mess with the results due to the bubble. The light passing through it will not be able to measure properly. Hopefully this won't, because the bubble just stopped. Yeah, so it's fine so long as there's no bubble. 6.947. Now I think I forgot to show you how the graph should look like for nucleic acid, so I'll just show you just once more. So again, for nucleic acid, you need TE. Like that. And blank. So while we're waiting for it to blank, for nucleic acid measurements, we usually recommend doing the lower concentrations first as you go and move up further, move up the concentration. Because if you do the higher concentration first and go back down to a lower concentration, that might, because of the residual stuff left on the pedestal, it might mess with the results. So even if you try to clean it as well as you want, it sometimes leaves some residue behind. So if you're going back down to lower concentration from higher concentration, then we recommend doing the blank again so that you can clean the pedestal using the blanks. Now, as you can see, the graph for this should look like this, with a dip around 230 and peak at 260 and going down towards 300. So this is how the graph should look like. If the graph looks differently, then you will probably need to blank again because that means there's a contamination somewhere on the pedestal. And if the graph looks really wrong and the ratios are also wrong, then that means there's something wrong with the sample. If, for example, the 260 to 280 ratio is around 3.5 or something like that, then that means the DNA purity has been compromised and you will need a new sample, or you need to vortex the samples again. Now, since I've shown you the results of how to measure using cuvettes and microvolume as well, I'll show you how you can use the other functions that Nabi has. So if you were to look at the main screen over here, we have other setup, account, search, and power buttons as well. So if you press accounts, you can add new accounts, or you can swap between the accounts you want. So for example, if you wanted to add a new account, just set up an ID. Let's say test. And simple as that. You make a test account. If you want to swap to it, press swap. And since there's no password, just press OK and you've swapped. Or you can also edit an account. Yeah, you can edit the name of the account by clicking edit. You can enter, since I didn't put a password last time, you can just enter a password you want. Let's say 1, 2, 3, 4. And retype the password. OK, and you have your password for the account. And if you'd like to delete an account, click the account that you want to delete, press delete, and we'll say, are you sure you want to delete the selected ID? Say yes, and you'll have to enter the password. So other people cannot delete your accounts that you've made. 1, 2, 3, 4. Okay, and it's gone. There's also a guest account that you can use in the beginning. So anyone who doesn't want to make an account, you can use the guest account. There's also the master account, but that's for engineers and technicians only. So I think only Kevin will be able to know this, the password for it. So next, you can obviously search for the results you want again. So for OD6 group, you can also set the date, the time that you want to search between. So if you want to search between, let's say, from July 18th of July all the way to 18th of August, then all you have to do is click that and click search. And obviously, since we didn't have any data at the time, it will say data cannot be found. But if you just click all, oops, yeah, so once the data is there, you can search it for it as well from this page as well. All right, since I just switched accounts, of course, sorry about that. I got confused for a second because I switched accounts since there's no results measurements you made with this account. There's no data, obviously, but then you cannot see this. Hold on 1 second, please. And we're back at master, and we'll be able to search the accounts. Apologies. If you click all, then you'll see the measurements that we did previously for OD. And if you click them, you can also click them multiple ones at once, and you can just click data transfer to use a USB. So you can transfer the selection or all of them at once. You can just click selection. But there's no USB connected to this right now, so it will say there is no USB disk. But if you have a USB, it will transfer the data to the USB. You can also delete the data. Press delete. Are you sure you want to delete the selected data? You say yes, and it's gone. So if you look at this, you click the data you want to see, you press detail, then you'll be able to see the measurement wavelength and absorbance that you got for that data. And if you were to look at nucleic acid, results, all, and click the data you want to see. If you click multiple ones at once, and if you press detail, you'll be able to see them overlaid like this. So 3 results with 3 different concentrations showing the same looking graph, just slightly squashed for the lower concentration because of the concentration range for the y-axis. You'll be able to see this, and you can also even capture this, but you will need to have USB disk, USB drive, which is on the side here. You can see if you have a USB inserted, then you'll be able to capture the results that you want to show. And simply just press back, and you can come back to this search page. As for the setup, there's not much that non-technicians can do, but if you ever need to look at the system information, all you have to do is press this, and you'll be able to see the version information for the UI, the software. You'll be able to see the serial number and who it's made by. So serial number, this one is MB1E 22108004, and the version is 3.705. We have a new version of software to once every 3 months or so that we can, because we get feedback from our users and our partners on features they want to add or bugs that might ever be present in the software, and we usually update them for you if you ever need them. And also you can format the database by clicking this and get rid of all the result data. or you can also get rid of all the user accounts. You can also get rid of the standard curve that you made for protein measurements, or you can just format them all at once. We recommend formatting the data at least once every 1 or 2 years, because the memory is not the problem, but it might slow down the software itself if there's too much data. So back up everything and then format result data, and we'll remove everything that you want. Next, you can set the time. It's currently 12:06 in Korea, so the time is 12:06 here. And you can set the date as well. Just click OK, complete. If you ever have a software update, I think technicians will do it for you, but all you have to do is get the software, the new version of the software in the USB, insert the USB to the side of the machine, click update, and it will just do everything else for you. But currently, obviously, no USB disk, so this error will come up. And actually go back to if there's also the master setting, which you really should not touch if you're not a technician and you do not have our guidance on how to set the master settings. And that's about it. Does anyone have, if you have any questions about the Nabi functions or